Good day, grade 12 learners. Welcome to today technical science lesson. My name is Tabang Mongatani. This lesson is brought to you by Gauteng Department of Education in collaboration with Cybono Discovery Center and broadcast by Pagama Research and Development. Welcome grade 12s for the 19th Technical Science grade 12 lesson. Remember, as always, we have our WhatsApp line that is open for you to ask any question. And then we have our team that will be helping to answer those questions. The number that you can use for WhatsApp is 060-667-5044. Let me repeat the number. The number is 060-667-5044. Grade 12s, we are continuing with the lesson that we started on the 8th of April. It is elasticity, viscosity, and hydraulics. Before we start with everything, we will be looking at how the paper will be when you're writing the final exam and the prelim exam. We said mechanics is 93 marks and which weighs 62%, and electricity and magnetism is 33 marks, which weighs 22%. Wave, sound, and light is 24 marks, which weighs 16% of the whole paper. And the total of the paper is 150 marks, and the duration is 3 hours. And then we're saying there's level 1 questions, they are 25%. Level 2 questions, they are 30%. And level 3 is 40%. And level 4 questions is 5%. And then you can see that on level 1 and level 2, total of level 1 and level 2 questions is 55%. That means grade 12, it is possible that we can all pass these exams in technical science. Okay, we continue with the structure of the paper. The paper, section A, the paper has section A and section B. Section A, which is multiple choice question, and then section B is structured or long questions. We're saying in multiple choice question, we know that we have 10 multiple choice questions. Each multiple choice question is 2 marks. That means if we have 10, that means we have multiple choice questions is out of 20 marks. And then we say section B, which is structured and or long questions, takes 130 marks. In a long question, that's where you'll find the definitions, stating the laws, and calculations. And that's where we need you to explain also. We say the paper, as we said before, is out of 150 marks, and duration is 3 hours. And then we say the topic of elasticity and hydraulics, and it cost about the whole section is about 36 marks, grade 12. Never mind what we wrote here is what is about 36 plus minus 36 marks. Okay, let's continue with the flow chart. We started with elasticity on the 8th, and then we managed to cover the deformation, the deforming force. We covered the restoring force. We covered the perfect elastic body, and we covered the perfect plastic body. We managed to cover also the stress and the strain. That means today we are going to start with Hooke's law. Okay, And then after we're done with Hooke's law, we'll continue with viscosity and hydraulics. This is what we'll be looking at under viscosity and hydraulics. We'll be looking at viscosity, which is separated into the effect of viscosity by the temperature and the motor oil viscosity. And under hydraulics, we'll be looking at what? Thrust. We'll be looking at pressure. And pressure is divided into three subsections, which is the fluid pressure, Pascal's law, and hydraulic lift. And then this, what you see here is formulas that we got from the formula sheets. These formulas are for what? Elasticity, viscosity, and hydraulics. You can see here, this is the formula for what? Elasticity, and then it is for stress, and this one is for strain. And then you can see here, this is the formula for modulus, and then this is the formula for when we use this formula when we're calculating for the hydraulic lift, where we'll be looking at the force and the area. Okay. Also, these definitions are what to look for when we answering the definition questions. We're gonna repeat it again today. We say the following definitions are very important and they must be mediated and be known by heart. Grade 12s, it is very, very important that before you sleep, you practice at least 2 definitions every day and make sure that you know them before you sleep. Always follow the definition from the exam guideline, not definitions from the textbook. We always follow the exam guideline definitions. All definitions are awarded 2 marks if the definition is correct. If you write correct definition, that means you'll get 2 marks, grade 12s. If the definition is not correct, 0 mark will be awarded. You see, grade 12s, it is important that you give us the definition that is correct and it comes from the exam guideline, because you lose marks. We have so many definitions in the exam and even in the test that we don't want you to lose those marks, grade 12s. We say if some part of the definition is correct and some part is incorrect, 0 marks will be awarded. That means it's either you get 2 marks or you get 0. There is no way that we can give you 1 because one part is correct and the other part is incorrect. All the laws stated correctly will be awarded 2 marks. We have definitions and we have laws. We define and we state the laws. And then we say now, if you state the law correctly according to the exam guideline, you will get that 2 marks. And then if the law is stated incorrectly, then you will get what? 0. There is no 1 mark also even in the laws. If part of the law is stated incorrectly and the other part of the law is stated correctly, the 0 mark will be awarded. It's important that you mediate these laws, you know them by heart, so that when it comes to the test and the exam, you are able to give us the correct laws and definitions. And then questions on laws and definitions can be or will be asked in question 1. We know question 1 is what? Question 1 is a multiple choice question. That means you will find these definitions and these laws in multiple choice questions. You will be given the laws or definition and ask the name and ask to name the law or the definition. Sometimes we'll give you a long sentence and we ask you to give us the definition, the name of the definition, and the name of the laws. Sometimes we just give you the law, and then we want you to do what? To state that law. Are we together, grade 12? Yes. We say now, most of the long or structured question normally will start with the definition or stating the law. Like question 2, question 3, question 4 in the test and in the exam, you will be asked to normally they start with what? Stating or defining. Stating the law or defining. Okay. Today, as I mentioned when I started that, we'll be looking at Hooke's law. This is Hooke's law, and then Hooke's law states that within the limit of elasticity, stress is directly proportional to the strain. Stress is directly proportional to the strain. That you can look at this. This it means that this sign that you see in between here, it says is what? It says are directly proportional. When you see this, always you must know that it stands for what? Directly proportional or proportional. And then from this formula here, we can say K is equals to stress divided by strain. We multiply both sides by strain, and this strain will cancel this strain. Then we'll have stress is equals to modulus multiplied by what? By strain. And if we're gonna remove this as a K here, it's act as a constant. Then this is a modulus, we say it act as a constant. Then we can say now stress is directly proportional to the strain. We know, as we said, this is the strain, stress, and this is what? The strain. When we continue, we say K here. K that you see here, this K here is what? Is modulus of elasticity of the material of the body, which is what? A constant, as I mentioned before. And we say the SI unit for modulus is what? Is Pascal or PA or Newton per meter square. Is what? Pascal or Newton. I'm trying to, we said this sign that you see here. This sign that you see, my pen is stuck, doesn't want to write. Okay, yes. With this sign that you see here, it stands for what? It means that proportional. When you see this sign, you must know that it's what? It is a proportional. It says proportional. And here we're saying from this formula here, we have a stress divided by strain, which is equals to the modulus. And then we said when we multiply both sides by a strain, then strain will cancel strain, and then we're left with what? Stress equals to modulus multiplied by strain. And then now, because we say K, it is what? Is a constant. Then we can easily say stress is directly proportional to the strain. Not equals to the strain, but directly proportional to the strain. Don't confuse these two grade 12s. We have a proportional and equals to. Don't confuse them. Okay, we say K, which is the modulus, is what is the Ke is the modulus of elasticity of the material of the body or the object, which is a constant. Ke is a constant. That is why you'll find Ke, you'll say, when we do this formula, write it like this. You can see now this will act as what? As a constant. Then sometimes they can ask you to draw a graph. Then when you see this, because now it tells you that stress is directly proportional to the strain. Now you can easily draw a graph, and your graph will be what? Is an increasing graph like that. Because of what? Ke now, it is what? It will be your constant. And when stress increases, that means the strain also will do what? Will increase. That is why we're saying it is what? Directly proportional. And then we continue by saying the SI unit for what? For modulus is Pascal or PA or Newton per meter squared. Newton per meter squared. That is the SI unit for what? For modulus. And then we continue by saying the reason why it is Pascal or Newton per meter squared is because of what? Remember, this doesn't have a unit. Are we together, grade 12s? The strain do not have a unit. Then if we say K is equals to, if we say K is equals to what? Is equals to stress divided by what? By strain. Then, and this doesn't have a unit. That means K will take the unit of what? Of stress. Stress is Pascal or Newton per meter squared. Okay, we have an example on Hooke's law. Okay, let's take 2 minutes to look into the Hooke's law. Take 2 minutes, just go through the question, and we'll come back and continue with the example. Thank you.
Believe in yourself. Believe a little more in yourself, because to those that believe, nothing is impossible. You have done this before. You have passed your tests before. You have went into a higher grade before. It is possible because you have done it before. Do not doubt yourself. Keep believing in yourself. Keep pushing, because this can be done and you can be great.
Thank you, grade 12. Welcome back. We had just a slight problem. We'll start from Hooke's law. Because of load shedding, we lost connectivity connection. Okay, Hooke's law, it states that within the limit of elasticity, stress is directly proportional to the strain. I've mentioned that this is not a strain, but it is strain. It is strain. Yes, we say Hooke's law, it simply means that stress is directly proportional to the strain. And then by looking at the formula, this formula here, we have a stress and a strain. And in this case that you see here is the modulus, it's a modulus. And then we say now, from this formula, we can say strain divided by what? Divided by stress divided by strain is equals to modulus. Then we multiply both sides by the strain. Then we say stress will be equals to modulus multiplied by what? By strain. Okay, strain. And then we say, because this is the constant, then stress will be directly proportional to the strain. We continue by saying the modulus of elasticity of material of the body, which is which is a constant. This K that you see here is the modulus of elasticity of the material of the body. We say also the SI unit for modulus is what? Pascal or Newton per meter square. The above equation is used to calculate what? The stress, the strain, and the modulus. And then stress and modulus have the same SI unit, which is what? Pascal and Newton per meter square. Strain has no unit. That's what we say. Can we take a 30-second break? Okay, welcome back. Hooke's law example. Then let's look at this example. Example, it says one end of the wire, which is 2 meters in length, is attached to the ceiling up there at the ceiling, and that means it is hanging. And then it says it has a cross-section area in the form of what? Of a circle with a diameter of what? Of 3 millimeters. And an 80 kilogram mass piece is attached to the other end of the wire. One end is attached to the ceiling, then the other end is attached to what? A mass of 80 kilogram. Then we say, due to this, the length of the wire is increased by 4.4 millimeter. That means the wire has now stretched by 4.4 millimeter. The mass piece does not touch the ground. After this, the wire has stretched, the mass piece does not touch the ground. And when you have a question like this, grade 12s, the first thing that you need to do is to do what? To write down given data. Others will say data. And data that we given now is what? Data we have given what? Length of 2 meters. And then we're given what? Diameter of what? 3 millimeters. And the length is now increased by what? The length now is increased by what? By 4.4 millimeters. If you have, and we have a mass of what? Mass is equals to 80 kilogram. We need to do conversions. Remember, everything must be in meters because the SI unit is what? Is meters. This one is correct. Then we need to convert this one into 3 millimeter and 4 millimeter into meters before we start doing everything. Then when we convert 3 millimeters into meters, we need to divide by what? 1,000. Then it's gonna give us what? 0.003 meters. And this one also, the 4.4 millimeters, we need to divide by what? By 1,000, and it's gonna give us what? 0.0044 meters also. Then, because now we are done with our data, we can simply go to the questions. The first question, 1.1, says, state Hooke's law in words. And then we know Hooke's law again. Remember Hooke's law? It says what? It says within the limit of elasticity, stress is directly proportional to the strain. Within the limit of elasticity, stress is directly proportional to the strain. That is what Hooke's law say. And then the 1.2, it says what? It says calculate the stress on the wire. And then 1.3, it says calculate the strain on the wire. And 1.4, it says calculate the wire's elasticity modulus. Calculate the wire's elasticity modulus. Then we go to solutions. The first one, it says what? 1.1, it says state Hooke's law. Here is what we have stated the Hooke's law. We said what? Within the limit of elasticity, the stress is directly proportional to the strain. And then this is the given data. You can see we managed to convert everything into the specific units. Like mass, it remained in kg. 2 meters remain as 2 meters because that is how we want it. And then we continue by saying the length, the diameter, it was 3 millimeter, now is 0.003 meters. And at the increased length, it was 4.4 millimeter, now it is 0.0044 meters. And then question 1, they said calculate what? Question 1.2, they said calculate the stress. Calculate what? The stress. This is the formula that we use to calculate the stress. It is there in your formula sheet. It will be given to you, my grade 12s. It will be given to you. You don't need to memorize this. You just need to be able to select it, to choose it, or to choose it from the information sheet. And then we know the force. The force that is acting on a hanging object is what? It is a gravitational force. That is why we use what? Mass multiplied by what? Gravitational acceleration. Then we say the mass is given to be 80. This is the mass. And we know that the universal gravitational is a constant is equals to 9.8. And now the area, let's look at the area. They told us that the cross-section area is a circle. It forms what? A circle. That is why the area will be equals to pi radius squared. And then you'll ask yourself, radius is a half of a diameter. If you have a diameter as 3, that means your radius will be 1.5 millimeters. I see most of you asking themselves, where does this 1.5 comes from? It is a what? A half of a diameter. It's a half of a diameter. And you're asking yourself, what is this funny looking letter there? It is a pi. We call it a pi, and it is equals to 3.14. It is what? Equals to 3.14. And then because the radius, you see here, this square here, we are squaring only the radius. Are we together, grade 12s? We are squaring only the radius. And then you can see now, when you say this multiplied by this, it gives you this. And then this, all of this, will give you this. And then when we multiply this with this is the answer that we get. We get 1.11 times 10 to the exponent 8 Pascal. Don't forget to write the unit. Don't forget to write the unit. Okay, we continue by saying 1.3. They said calculate what? The strain. The strain, this is the formula that we use to calculate the strain. And remember from last time lesson, we said this is change in length is the length that the rope or the wire have stretched with. Are we together? The length that the rope or the wire have stretched with. And then this is the original length of the wire. That is why now, because here you can see, we say 0. What? It's stretched by what? It's stretched by 0. Oh, sorry, this is a mistake. It's supposed to be 0.044, not 0.03. Ne? That means here we'll say 0.0044 divided by 3, which is equals to it will give us 0.001 something. Can you use use a calculator to do that? Replace 0.003 by 0.0044 because we want the length that the wire has stretched with. Sorry for that. And then you just say divide by 3 and then you'll get what? You'll get the answer. And then when we continue toward modulus, you can see now this also will change. It's not going to be 0.001. It will be, you'll take the answer that you got when you say this answer, it comes from where? It must be 0.0044 divided by 3. Then you put it here, and then this will also change. The answer, the final answer will also change. Sorry for that misunderstanding. If you have any question, please continue to WhatsApp us on 060-667-5044. Okay. If you have any question, please WhatsApp us 060-667-5044. Now we're going to viscosity. Viscosity. What is viscosity? Define viscosity. Viscosity is the property of the fluid to oppose relative motion between the two adjacent layers. That is what viscosity is. It does what? The important thing is to do what? It opposes what? Relative motion between the two adjacent layers. That means it doesn't allow the liquid to flow. It doesn't allow the liquid to flow. It does what? It resists the flow of a liquid. That is why here we're saying viscosity is a measure of a fluid resistance to flow. Like for instance, when you have a water and an oil, which one can flow easily? Water can flow easily. That means water will have less viscosity. Oil, because it doesn't flow easily, then it has what? Higher viscosity. Are we together, grade 12? We say the viscosity of liquid decreases rapidly with an increase in temperature. Okay. Let's look at this. I have an oil and I have a cold oil and the oil that I've heated. Which one will flow easily? The heated one will flow easily. Are we together? That means when you increase the temperature of a fluid, that means you are decreasing what? The viscosity. Are we together? When you increase the temperature of a liquid, you are decreasing the viscosity of that fluid. Okay, we say here, the lower the number, the less the oil thickens in cold weather. This one, grade 12s, it comes from the oil that we put into our engines. I know you know more than me when coming to cars. We say when you buy the oil has this kind of numbers. You'll see there is a number, there is a W, and another number. What does that mean? It means that when it is cold, the viscosity is 10, and then when it is hot, when the engine is hot, the viscosity tends to what? To be 30. Are we together? The viscosity become more. Are we together? Then, like for instance, here we have what? We're saying 10W30. If you buy an oil, a can of oil, check outside what is that written. And then if it's written 10W30, it simply means that it is more viscous than this one. Because we see here, this one is warm and this one is colder. Then this one can handle more heat. This oil here can handle more heat than this one. It's not gonna be, remember, if the oil, the reason why we're using different oils is because of what? When the oil become hot and then you use the wrong oil into your engine, that oil will become so, it will flow so easily and it will get into other parts of the car, which is not good for the car, for the engine of the car. Like for instance, we say now, if you have an oil that is 5W30, is less viscous than, and therefore can reach even difficult parts in the engine for lubrication. Are we together? And we don't want that with your car. We want to put in the oil that can handle the heat of the engine. We say also, but this is not possible with this. If you have this one will be able to, will heat up and then will go to other parts of the engine. But this one, it can't, because it is what? It is meant for, has higher viscosity. because, and we say also it is what? It is thicker. That means when you check this one, when you check this one and this one, when you compare them, you'll find out that this one is thicker and this one is not thicker. It is like lighter. It's not thicker than this one. Are we together? Then we continue with saying, if I have this oil, motor oil, it means that viscosity is at 10 when the engine is cold and 30 when the engine is what? Is hot. This is what I said before. And then we say this oil is much thicker than this one. Can you see? This one is more thicker than this one. Are we together? This oil is more thicker than this one. It's more, even more thicker. Okay. Then let's look at this example concerning the viscosity. We have a multiple choice question. It says the viscosity of a motor oil increases when the oil decreases. What increases the viscosity of oil? What makes it? It's what? Is it a mass? No. Density? No. Pressure? No. But what? The temperature. If the temperature become less, that means the viscosity become more. That is what we said. We said the viscosity increases when it is what? When the temperature decreases. Or viscosity decreases when the temperature increases. Are we together? The viscosity increases when the temperature decreases, or viscosity decreases when the temperature increases. Can you see? That is how it is. The temperature is the factor that will increase or decrease the viscosity of any fluid. It's not only the oil, but it can be any fluid. Okay. Example, we continue with the example. We have here, they say, 3 hydraulic liquids, A, B, and C, are available with rating of A, this is A, 10W30, B, 20W30, and then C, this is B, and this is what? C with what? 20W40 respectively. Are we together? Now they want you to do what? Define viscosity. What is viscosity? And then 1.1 they say define viscosity. And then 1.2 they say what? Which one is the most suitable for the engine if you want to use a liquid that flow the easiest in winter. Are we together? Sometimes we don't need the thick oil. We need the one that can flow easily. Are we together? Then which one can flow easily out of the 3? Is it A, is it B, or is it C? Then the solutions says, the first one says, define viscosity. We say viscosity is what? Viscosity is defined as the property of the fluid to oppose relative motion between the two adjacent layers. Now, 1.2 it says, which one can flow easily out of the 3 given oil? The first one, A, B, and C. Then the answer it says is what? Is A, because in winter we expecting the oil to be thick. Ne? But now we need the one that can flow easily. That means we don't want the one that will be more thick. We want the one that can flow easily, which is gonna be what? A, or 10W30. Are we together, grade 12? We have a question. Ask the question. Don't hesitate. We'll answer your question immediately. Now we come to hydraulics. This is very, very interesting because hydraulics, we see hydraulics in many machines that we come across, heavy machines that we come across in our everyday life. Hydraulics. Define hydraulics. What is hydraulics? Hydraulics is a topic in science and engineering dealing with what? Mechanical property of liquids. That means here we use a liquid so that we can have what? A mechanical forces. We use what? Liquids so that we can have what? Liquid can give us mechanical forces. And then another thing that we can look at under hydraulics is what? Thrust. What is thrust? Thrust is defined as the normal force exerted by a liquid at rest on a given surface in contact with it. If I have a surface like this and I exert a force on it, a normal force, then the surface will do what? Will exert a normal force. That is what we're calling what? A thrust. That is what we call a thrust. It's what? It's a normal force. Remember, what is a normal force? Normal force is the force that the surface exerts on an object. Are we together? It's a force that the object, the surface exerts on an object, and it is perpendicular to the surface. Okay. Another thing that we're going to look at, another definition that we're going to look at is what? Is pressure. Pressure. Pressure at a particular point. We're not talking about a pressure. We're looking at, if you have a container like this, we might need a pressure at the bottom here. The pressure of this water at the bottom here. Are we together? That is why now we're saying a pressure at a particular point is the thrust acting on the unit area around the point. If like we need a pressure of this at the bottom here, then we know that the water exerts a pressure on the surface of this container, and then that a normal force, it is what? It is a thrust. Then it gives us what? It gives us what? It gives us a pressure. And that force that is exerted there, we're looking also at the area. Are we together? You can't have a pressure if you don't have a force and the area. That is why our formula says F divided by what? By area. Force divided by area. Are we together, grade 12s? And then remember, what is a thrust? Thrust is a force. It's a force. That is why here we say a pressure is equal to thrust divided by what? By area. It's a force divided by what? By area. Are we together, grade 12s? Then we continue. If pressure is equal to thrust divided by area, the SI unit for pressure is still what? Pascal or Newton per meter squared. This Newton, it comes from where? The force, and meter squared per meter squared comes from the area. Are we together? Meter squared comes from the area. We know that the unit for area is what? Meter squared. Okay. The above equation will be used to calculate what? Pressure, to calculate thrust, and the area. Are we together? And sometimes you can still use the same to calculate even the radius of the surface of the area. Are we together? And then we say practical units for pressure is what? ATP, which stands for atmosphere. we have atmospheric pressure, which is equals to what? 101. 3, it is equals to 101,325 Pascal. 101,325 Pascal. And then we say also we can, it's either we can use the pressure in Pascal or in bars or in ATM or in torr. Are we together? That means we can ask you a question to do what? To convert pressure into Pascal or into atmosphere or into bars or into torr. When we're doing that conversions, we'll be looking at what? 1 ATM is equals to 101,325 Pascal. And then one bar is equals to 10, grade 12. This is supposed to be 10 to the exponent 5 Pascal. Is what? 1 bar is equals to 10 to the exponent 5 Pascal, which is the same as what? 100,000. Sorry, 100,000 is equals to 100,000 Pascal. Are we together? Because of this 5, we must have 5 zeros. 1, 2, 3, 4, 5. Which is 100,000 Pascal. And then torr. 1 torr is equals to 133 Pascal. Can you see? 1 torr is equals to 133 Pascal. 1 bar is equals to 100,000 Pascal. 1 bar is equals to 100,000 Pascal. Okay. Then let's continue. Hydraulics definitions. We continue with hydraulic definitions. We have something that we call fluid pressure. Fluid pressure. A fluid pressure is given by the following equation. This is the fluid pressure. Are we together? Which is what? P, density, gravitational acceleration, and the height. We have P is for pressure. This is for density. It's not P, ne? It's not P, and it's not even small p, ne? But it stands for what? Density of the it's written like this. It's written like this. Ne? It is the density of the liquid. Then G is a gravitational acceleration, and the H is what? Is height. Then the above formula will be used to calculate the pressure, the density, and the height. Can you see? Yes. Then we continue. We have something that we call Pascal law. Pascal law states that in a continuous liquid at equilibrium, the liquid should not move. Again, liquid must be in equilibrium. The pressure applied at any point is transmitted equally to other parts of the liquid. That means the pressure that you can find here at the bottom is the same as the pressure that you can find at the top. Is distributed equally. Is distributed equally. Are we together? We say a Pascal law states that in a continuous liquid at equilibrium. When you say continuous, that means you're looking at this liquid here. It's not separated. The liquid in here, in the bottle, is not separated. That's why they're trying to tell you. And then they said what? And the liquid must be at what? At equilibrium, should not move. Then the pressure that you find here at the bottom will be the same as the pressure that you can find anywhere in the liquid. Okay, now let's continue. We say another definition that we need to look at is what? Hydraulic lift. Hydraulic lift, we know it is what we used water to lift other things. It is used where in heavy machines, or it is used to carry heavy loads. Like when we carrying big, heavy tons of material or of objects. We say in hydraulics based system, mechanical movement is produced by pumped the liquid onto the container that have small piston. Are we together? You'll find that now we have something like this. We have a container here with a big piston, and then we have a pipe where we can do what? We can have a small piston this side. And then when the liquid is pushing, when you push this, let me draw. Okay, now we have what? You'll find that you have something like this. Can you see? Here you have a big piston. Here you will have what? A small piston. When you push here, this piston will push the liquid, and the liquid will push the big piston to give you more force. That means the force that you're going to use this side is not going to be equal to the force that you'll get this side. The force that you'll get, you'll use here will be smaller. And the force that the output force will be bigger. Are we together? The input force will be smaller. The output force will be bigger. That is why we are able to carry big things by applying a small force. Okay. Yes. And then where do we use this hydraulics in everyday life? We say the car brakes. It is so amazing that the car brakes, by applying a force, small force on the brake, you can stop a car that is moving at 180 kilometers per hour. Because of what? The hydraulics. And in the dentist chair, we know when you go, the reason why the dentist chair can carry you and can take you from to different positions is because of what? This hydraulics. Car lift, when you go to, there are things that we use in a scrapyard or a mechanics in the garage. There are things that they use to carry the cars, and they are applying only a small force. Then they can get that force that they applied as an input. Then it will produce an output force that will be able to carry a heavy car. Car jack, the hydraulic one, you know, the one that has a oil, the one that you pump it like this, and then there is a piston that's going up, straight piston will go up like this to pick up the car. And remember, you're only applying a small force when you're pumping that jack, but it can carry a car. It will carry car upwards. And then they say airplanes. I've never seen this one. Airplanes, how is it used? And then the theme park. The theme park, when you go to for entertainment in summer, yes, that thing it use what? Hydraulics also. The crane we use it when we're building big buildings. The tall metal structure that you use to carry heavy things when they're building the big buildings. And bean wagon, you know, that a bean that was put it there on your yard when you're doing the construction, and then after you put in the bricks, and it can be the truck come and carry it. That is what is it also uses what? It also uses a hydraulics. Then we're saying in hydraulic lift, the formula that we use is this one here. And then we say the area 2 is bigger than area 1. The area that we're looking here is the area of the pistil. Are we together? This is the area, smaller area, and the bigger area. That means this is A2, this will be A1. Are we together? This is the bigger area, is the area of the bigger pistil. Are we together? Then we say from this formula, this is the formula that we're going to use when we're using hydraulic lift to calculate how much this hydraulic can carry. How much force will it be able to produce? Are we together? How much force will it be to produce? If, let's say for instance, I exert here 50 newtons, and in this area here is how much? Is 2 square meter. Are we together? And the area here is 7 meter square. Then how much the force will this? How much will be the output force? Are we together? This force 1, is the force that I will be applying. And then force 2 is the force that will be the output force, the force that the system will produce. That will be bigger. Are we together? Then that is why we said F1 stands for what? Is the force applied on the pistil with a smaller area, which is this force. F2 is the force produced. Can you see? Applied and produced by the pistil with the bigger surface area. And then A1 is what? Is this A is the area of the smaller pistil, and A2 is the area, surface area of the bigger pistil. Okay. Now we're saying the above equation will be used to calculate what? We use the above equation to calculate the force, the area, and the radius. Why the radius? Because we're calculating the area, and most of our pistil, they are circle. That means because we use a circle, then we are able to calculate what? The radius there by using this formula. This is the formula that we use to calculate the area of a circle. Are we together? We're using this area to calculate we're using this formula to calculate the area of a circle. And this R that you see here, it's what? It's a radius. Are we together? Sometimes we'll be given a circle like this with a diameter. We said diameter, a radius is a half of what? A radius is a half of a diameter. If the diameter is 4, that means radius will be equals to 2. Are we together, grade 12s? Yes. Okay. Let's look at this example. Under hydraulics, it says a cylinder is filled with water. The vertical height of the water is 2 meters. Can you see? This is the vertical height, is 2 meters. The density of the water and other liquids are given in the table. The densities, can you see the densities here? Of petrol is what? 715. The density of water is how much? Is 1000. And then the density of seawater is what? 1025. And you can see now, when we continue, they say, when you come to the example, they say, calculate the pressure in Pascal of water at point 0.5 meter from the bottom of the cylinder. That means from here, from this bottle, let's look at this bottle, from where the water is up to the bottom is 2 meters. Are we together? But we want it here. Then from here to here is 0.5. We want the pressure that is at this from 0.5. Are we together? And then if we want the pressure up to here, what does that tell us? That means the water from here to here is the one that exerts that pressure. You'll see when we do we give you the solution. That means this is 0.5. That means 1.5 is the one that exerts the pressure on this water that is at the bottom. Are we together? Yes. And then 2, they said, convert your answer from 7.2.1 into bars. It is given in Pascal. Now they want it in bars. And then 3, which one of the other liquids in the above mentioned table will exert a lower pressure than water at the same point in the cylinder? Give a reason for your answer by referring to the mathematical relationship. Okay, now we come to the solution. First, we write down the data that is given to us. The height is 2 meters. The density of water is 1,000. And the pressure, where the pressure is 0.5. The height of that is what? 0.5 meters. Then now, they say, calculate what? Pressure. Number 1, calculate pressure. This is the formula that we use to calculate the pressure. We know the density. This is the density. This is the gravitational acceleration. And this is what? 1.5. Where does 1.5 comes from? We said 2 meters minus 0.5. This 0.5 that is given, which gives us what? 1.5 meters. That's where the pressure comes from. This is the water that is 1.5 is the one that exerts the pressure on the bottom water, 0.5, the water that is 0.15. And then when we do this calculation, we found that it gives us 14,700 Pascal. Are we together? You can use a calculator and you'll see if you get the same answer as I got here. Okay, now number 2, they say we should do what? Convert this pressure into bars. We need to convert it into bars. And then when you convert it into bars, we just take what we have here and we multiply by x. This we just come up with x. And then we say is equals to 1 over 10 to the power 5. This is supposed to be 10 to the exponent 5. This is supposed to be 10 to the exponent 5. Then you say 14700 x is equals to 1 over 10 to the exponent 5, which we're going to do what? We're going to say, how do we do this? We take this, we multiply both sides by 10 to the dead. We multiply even this side by 10 to the 5. And then after we did that, then x is going to be this, cancel that. Then we do what? Oh, no. Sorry, I'm doing it the wrong way. I'm doing it the wrong way. Sorry. It will be, we're saying 1 14700 x is equals to 1 over 10 to the exponent 5. Then what we do, we divide both sides by what? We divide both sides by 14700 divide by 14700. Then we'll get what? Then x will be 1 over this, which is gonna be 10, 5 multiplied by 14700. It gives us this 0.147 bars. It gives us this, as the answer is this one. Or alternatively, you can do it like this. You can do it like this. You have 14700x is equals to 10 to the exponent 5. Then what you do is to do what? Multiply by 10 to the exponent 5, multiply by 10 to the exponent 5 this side, and then this one will cancel this one. Then you have this. Then your x will be, you need to divide 10 to the exponent 5 multiplied by 14700. You divide by that in both sides. Then you'll be having, even this side, you're going to have what? After you have 1 here, is what? 14700 x is equals to 1 over 10 to the exponent 5. You start by doing what? Can you see? Then we cross multiply. This comes here and this goes there. Then we'll have what? 10, 5 times 10, 14700 x, which is equals to 1. Then we divide by 10, multiply by 14700. Sorry, it's 2 zeros. It's not 3 zeros. Divided by 10 to the exponent 5, multiply by 14700. Then x, this will cancel this. Then we left with x this side, and then we left with this on the other side. And when you manipulate this, it's going to give you what? 0.147. Yes. Yes. Okay. 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 And then let's continue. When we continue, we're going to say, when we continue, number 3, they say, which one of the liquid in the above mentioned table will exert a lower pressure than water? Let's go back. You can see the one with the lower density is what? It's a petrol. This one, because when you're looking at the formula says P is equals to density gram H. The density is directly proportional to the pressure. Are we together? The density is directly proportional to the pressure. And that means when you increase the pressure, you will be increasing the density. Are we together? Or when you're increasing the density, then the pressure will increase. When you decrease the density, the pressure will decrease. That is why we have what? Pressure. The answer here is what? Is going to be petrol, and the reason is what? Is pressure is directly proportional to the density. Are we together? The reason you'll say the pressure is directly proportional to the density, because the petrol has the less density. That is why we'll give less pressure. Are we together? The petrol has less density. From the table you can see the petrol has less density. That means we'll give what? Less pressure. Are we together? Yes. Then we have an exercise here that I want you to take as a, let's go through this quick. It says, okay, the diagram below shows a hydraulic lift. A force F1 of 200 Newton is exerted on piston 1, and which has a circular area of A1. The radius of A1 is 2 centimeter. Piston 2, which is also circular in shape, has the area of A2 of 6.158 square meter. Then they say, number one, they say state the Pascal law in weight. And then they said, number two, they said calculate the area 1. Number 3 say calculate the force 2. And then number 3, they say the distance between the two pistons. Calculate the distance between the two pistons. Okay, they said the distance between the two pistons is decreased by using a shorter pipe. How will it affect the answer to 2.2.2 to number 3? It's supposed to be to number 3. Write only increase, decrease, and remain the same. And number 5, they say name 2 uses of hydraulic system. Are we together? The first one, state the Pascal law. Number 2, calculate the area 1. Number 3, calculate the force 2. And then now they say you have decreased the pipe. Then will that affect the answer that you calculated in F2? That is the question. But you're only writing increase, decrease, or remain the same. And the number 5, they want 2 uses of hydraulic system in everyday life. Then the solution is number 1. In a continuous liquid at equilibrium, Pascal law states that, Pascal law states that in a continuous liquid at equilibrium, the pressure applied at a point is transmitted equally to the other parts of the liquid. That is how we state Pascal's law. And then number 2, they said calculate area 1. And because the area 1 is a circle, then that is why we're using this formula here. And this 2 here, it's supposed to be a square. The formula will be pi r squared, like this. Then when we do that, we see that it's what? 1/4 times 0.022. Where do you get 0.022? 0.022, it comes from here. Are we together? 2 centimeter. Radius is 2 centimeter. And then how do you get to 0.022? It's because of what? We said we took 2 centimeter, converted to meters, it gives us 0.02 meters. 2 centimeter converted to meters is 0.02 because we divide by 100 here. And then when you square this, it gives you 0.022. Negative 12, it gives you 0.022. It's supposed to, it's not 0.022, it's 0 squared, 0.02 squared. 0.02 squared. This 2 here, it's supposed to be squared here. Then we say that means you're going to have 3.14 multiplied by 0.02 squared, which is going to be 1.26 times 10 to the exponent negative 3 meter squared. Ne? This, it's supposed to be here at the top also. Ne? Are we together? Yes. Then this is what how we use to calculate what? The area. And now let's look at how do we calculate the force. The force, we have this formula. We have this formula, and then F1 is given as what? As 250 Newton. And then F2, we're looking for it. And this that you see here, why now is 1.26 to the power 6. Okay, this is what is given to us is this. Is the area of the bigger, bigger pistol. And then this is the area that we got from here. Are we together? Is the area that we got from here. And then excuse the 6, excuse the 6, supposed to be -3, -3 there. Then by using the calculator, then we got the answer to be 1.22 times 10 to the exponent 6 Newton. Are we together? Then how do we get that? This is how we got it. We're gonna say from this formula here. From this formula, we can say F2 is equals to A2 F1 divided by A1. Then we have A2, which is 6,158, multiply by 250 divided by A1, which is 1.26 times 10 to the exponent -3, which is gonna give us what? 1.22 times 10 to the exponent 6 newtons. Are we together, grade 12? Yes. And then number 4, when we change the pipe, will it make a difference on our system? Whether we have a long system, longer pipe or shorter pipe? No, it will stay the same. This force will remain the same, will stay the same. It's not gonna be affected by the shorter pipe or the longer pipe. Now, grade 12, if you have a question, you can still send us the question on 060-667-5044. Number 5, they said, give 2 uses of hydraulics. You can select from any of these hydraulics, select only 2. We have so many that, and you only need to select only 2. Okay? As usual, when we are reaching the end of our lesson, you'll always have a homework. Number 1 is a multiple choice question. Are we together? I'm going to ask you, because of time, to take a snapshot of the question of the homeworks. We have 1, 2, 3, 4. Let me go back, take a snapshot, or quickly copy the homework. Take a snapshot. I know that you have a fancy cell phones. You can take a snapshot. And then if you are done, the homework continues here. Take a snapshot, the second snapshot of the homework. And then these are the questions. Calculate the pressure exerted in the liquid. If the area A2 is that, calculate the output force. That is for F2. This will be F2. And then number 3, it says, calculate the mechanical advantage of the system. Calculate the mechanical advantage of the system. Okay? Thank you, grade 12, for attending today's lesson. Please don't forget to social distance, sanitize, and always put on mask. COVID-19 is still with us and it's still alive. Thank you very much.